In this video, I'm going to take you through how to solve this case about Bob the Builder Home Improvement Store. This case is basically about a retailer and a manufacturer and various contracts that they can set up and what is the benefits of those contracts. We'll first analyze the traditional purchasing contract, then the revenue sharing contract and the buyback contract. This is maybe homework 4 in the supply chain management course for you, or if it's not homework 4 and you have a similar situation, retailer and manufacturer, and you want to analyze purchase contracts or sourcing contracts, you can follow the logic and the analysis that we are going to do in this video. Okay, so we have some data about demand, we have some data about the 3 contracts, and then we have to find things like what will be the order quantity and what will be the profit for each of the 2 parties, the retailer and the manufacturer, and the total supply chain profit. Whenever you have to analyze a sourcing contract situation like this, especially using the tools we are going to use, what if analysis / simulations, you need to have some data on the demand. So for this company, Bob the Builder, which is a retailer, what are they doing? They are selling, or they're planning to sell, synthetic planks that people can use to build beautiful decks. Okay. They can get the synthetic planks from the manufacturer called Renata Manufacturing, and they have to decide how much to order before the selling season, because the lead time is long, and then during the selling season they sell those planks, because a lot of people build and use decks in summer. That is our selling season. Okay. In our discussions, in B2B's discussions with Renata Manufacturing, they have come up with 3 possibilities for the contract. A traditional purchasing contract is straightforward. So contract 1, traditional purchase. The retailer will buy planks at a certain price, in this case is $2.5 per linear foot, and sell them to the end customer at $3 per linear foot. So the retailer makes a profit of 50 cents per linear foot, and that's it. And the manufacturer's revenue is going to be based on what the retailer pays the manufacturer. So manufacturer's revenue is going to be $2.5 per linear foot. Notice that the manufacturer's cost is $1.5. So in the traditional contract, the manufacturer is going to have $1 of profit left over. If you think about the total supply chain profit, and under the traditional contract, the retailer makes 50 cents per linear foot. The manufacturer makes $1 per linear foot. So the total profit per linear foot that will be made if a plank is produced and sold would be $1.5. 50 cents plus $1, $1.5 per linear foot. So that is your traditional contract. Now, if you're not familiar with revenue sharing or buyback contract, you can refer to the lecture or the slides to review those. In this revenue sharing contract, the manufacturer gives a discount to the retailer, gives a lower price to the retailer. So in this case, Renata will sell B2B planks for $1.5 per linear foot. Notice that is the cost of the manufacturer. So the manufacturer is selling planks to the retailer at no markup, just at cost. So how will the manufacturer ever make any money? How does this make sense? Well, when the retailer sells that product to the final customer at a price of $3 per square foot, which is given here, then 75% of that revenue will be kept by the retailer, and 25% of that revenue, 25% of the $3 they get per linear foot, would go back to the manufacturer. And that's how the manufacturer will make money, from the 25% cut of the revenue. Contract 3, buyback contract, is the same as contract 1. So the same selling price between retailer and manufacturer. Manufacturer sells to the retailer at $2.5 a linear foot. However, the only difference from contract 1 is if at the end of the selling season, the retailer has too much inventory left over. Okay. has too much inventory left over, they can return the excess inventory to the manufacturer. So unsold planks, they can return them and get a refund of $2 per linear foot. So in other words, the manufacturer will buy back its own product at $2 per linear foot. And you might say, well, $2 per linear foot is less than what they sold to the retailer initially at $2.5. So if the retailer buys at $2.5 and returns for $2, they still lose $0.50 per linear foot, and that is correct. But notice what has happened here, that the cost of excess inventory for the retailer has gone down. Before, the cost of excess inventory was like $2.5. You have a plank you couldn't sell, there's no demand for it, it's gone. You made an investment of $2.5 and you have nothing to recoup for it. But instead of losing $2.5 per linear foot, now the retailer will only lose 50 cents per linear foot. So they have a lower cost of extra inventory that can encourage the retailer to order more than they normally would. Now, for each of these contracts, we have to figure out under that contract what is the retailer's order quantity. Obviously, the retailer is a rational actor. The retailer will try to maximize its own profit. So under each contract, we have to see, okay, which order quantity the retailer will pick to maximize its own profit. Then based on that order quantity, we can compute the profit of the manufacturer. And then we can add the profit of the retailer and the manufacturer to see what's going on with the total supply chain profit. Okay, so we have demand given here. So Barbara is a recent graduate of Flint. She's been tasked to help the retailer BTB, Bob the Builder retailer, with figuring out which contract to pick and how much quantity to order before the summer season. And her work with marketing has revealed that demand can be 8,000 linear feet or 16,000 linear feet or 24,000 linear feet. With these probabilities, the most likely scenario is demand will be 16,000 linear feet. It has a probability of 50.5 or 50% chance. But there is also a 1/4 probability or 25% chance of low demand, 8,000. Nobody likes these synthetic planks for some reason. People want to stand on real wood. Or there's also a chance everybody goes for or a lot of people go for these synthetic planks, and we sell 24,000 linear feet with a probability of 0.25 or 25% chance. Now, Barbara could choose an order quantity which is any number between 0 and 24,000, I guess, because doesn't make sense to order more than 24,000. That's the highest possible demand based on our judgment or estimation. And this is the so Barbara could order any number between 0 and 24,000. But to keep things simple, she's gonna pick either 8,000, 16,000, or 24,000 as her order quantity. Okay. Now, the analysis we're going to do next can easily be extended to allow Barbara to pick any number for the order quantity, and the way we do the analysis in Excel would still work out. Just make the Excel sheet a little bit more complex or involved. Also, if you have a more complex demand distribution, so you don't have 3 levels but 10 levels, 12 levels, or you have a continuous demand distribution or normal demand distribution, all of that can be factored into this analysis relatively easily. Because we're going to do like a what-if analysis / simulation, and can easily be extended to have different demand distributions and different options for the ordering quantity. Okay, so the goal is for you to understand the logic, how to build the model, work with a simple example, get your feet wet, understand the concepts and how to use different functionality in Excel, and then you can grow your wings, develop your skills, and go on from there in future. Okay, so let's set up the traditional contract in Excel, and I'm going to give you some tips on how to model that. And let's see what happens under a traditional purchase scenario. Okay, so what you want to do in Excel, and this setup you can use in many such modeling problems. So there's no formulas in this Excel sheet. These are all typed numbers from the question. So it's not that I've pre-set up the Excel sheet. I'm going to show you exactly how to do it from scratch. So whenever you're building a model in Excel, the first thing you want to do is have the inputs, the values you know from the question typed up. So usually in the top part of the model, I just type up the information I need from the case. So I know that the retailer sells it at $3 per linear foot, right? So this is the retail price, dollar per linear feet or foot from the case. So I put that in here. Manufacturing cost for the manufacturer's price, which is what the retailer pays to the manufacturer, is $2.5 a foot, and manufacturing cost is $1.5 a foot. Okay. So hopefully this is not too confusing. Think of it this way. The process starts at the manufacturer. The manufacturer produces it for this cost, but then they don't sell at cost. They sell at this price to the retailer. So the retailer, when they create the purchase order and they pay the manufacturer, they're going to end up paying $2.5 per linear foot to the manufacturer. That's the price charged by the manufacturer. So this price charged by the manufacturer is a price for the manufacturer, but a cost for the retailer, because it costs the retailer $2.5 to acquire the plank. Then the retailer in turn sells it forward to the end customer for $3 per linear foot. Okay, so this is the information we have from the case. We also have from the case probabilities of demand. So we have this demand distribution right here from the case, right? So the probability of 0.25 demand can be 8,000, probability of 0.5 demand can be 16,000 and 24,000 for the probability of 0.25. Then we also know from the case that Barbara is going to order 8,000, 16,000 or 24,000. There's no probabilities associated with these three numbers. Why? Because it's not a random event. It's Barbara's decision, which we have to help her make. So this is a decision. There's no probabilities here. Why did I put them up like this and this? Because I want to fill out this table to see for each combination of demand and order quantity, what is the profit of the retailer. Okay. And same thing for the manufacturer, except here it's not going to be order quantity. It's going to be production quantity, how much the manufacturer produces. And obviously this production quantity is going to equal whatever the retailer orders. So if the retailer orders 16,000, manufacturer will produce 16,000. If the retailer orders 8,000, manufacturer will produce 8,000. Okay. So for each scenario of demand and order quantity, we're going to have a retailer profit and a manufacturer profit, and we can fill out these tables. Once we have these tables, we can analyze that data to get some insights, which will also answer the questions given here. Okay. So, for example, question 1 is, what is the expected profit if 8,000 linear feet are ordered? So if 8,000 linear feet are ordered, there's a 25% chance our profit will be whatever value we compute here for 8,000 demand. There's a 50% chance our profit will be the value we compute here, because there'll be 16,000 demand, although we only ordered 8,000. And there's a 25% chance we will end up with this profit. So once we have the different profits for different demand scenarios, we can use the probabilities to find expected profit for this order quantity. Okay. Now, why I set up these tables will make a whole lot of sense, because we're going to use the data table feature in Excel. So hold your horses if you have questions about why these tables. They will probably be answered in the next few minutes. If you're with me with the model parameters, then we have inputs. Inputs are things that can change. These are the things that will change to give us different values of the output, which is the profit of the retailer and the profit of the manufacturer. So this right here is the output of our model, how much profit that players make. And this profit depends on these two quantities, which can change. The demand can change. It could be this, this, or this. And the order quantity can change. Barbara could pick this, this, or this. So based on the two variables which change, which is demand and order quantity, you want to compute the output of the model. The model should tell us how much profit each player makes. So let's do it. You could type any number here, doesn't matter. You could type demand is 8,000, and let's say Barbara ordered 16,000. It doesn't matter. You have to type, under order quantity, you have to type one of these three numbers here, and for demand, you have to type one of these three numbers here, one of these three numbers here, a possible number. And then once we compute, then we'll make Excel run through different numbers. So what number you start off with, is not crucial. You can start with 8,000, 16,000, 24,000. It doesn't matter. You're gonna go through all possibilities by the end anyway. So what is the revenue if demand was 8,000 and Barbara ordered 16,000? So this is a little bit tricky. Okay, you cannot multiply 16,000 by the price and say my revenue is 16,000 linear feet times $3 per linear feet, because even though Barbara ordered 16,000, in this case she can only sell 8,000 because the demand is for 8,000 and she'll have excess of 8,000. So the sales revenue, the sales quantity, is always going to be the smaller of these two numbers. Then imagine if Barbara ordered 16,000 and demand was only 8,000, then how much would you sell? You would only sell 8,000. Sorry, if demand was 16,000, Barbara ordered 8,000, yes, you would only be able to sell 8,000 even though the demand is more, right? Because you don't have any other stock to sell. How will you sell more than the stuff you have in stock? So that is why the sales revenue is always going to be the minimum of these two numbers, whichever one is smaller, times the $3, because your actual sales will be the minimum of demand and order quantity. So we just do min this number comma this number, whatever is the minimum, multiplied by the retail price. And we want to put dollars here. Well, I mean, you could put dollars on all of them if you want to, because this is the retail price here. We're not going to drag it down anyway. Okay, so in this case, that's how much revenue we make. Now let's try a different example. Let's say demand is 16,000. Okay, and Barbara, now notice if the order quantity is 28,000, nothing changed. But if Barbara ordered 24,000, notice her revenue went up, but not all the way up to 24,000 times 3, which is like 72,000 or something. It only went up till, because she could only sell 16,000. So the formula is working. Now we have to figure out whether, if she's short, how much quantity she's short. To be short means that you have demand but you don't have inventory to sell, so you have a shortage of stock to sell. And excess means that you have inventory to sell but no demand, so you have excess stock left over. Okay, so quantity short is always going to be you're going to be short by demand minus the order quantity. So quantity short will be demand minus the order quantity. Okay, now this is weird because quantity short should not be negative, but let me show you a scenario. Let's say demand was 8,000 and Barbara only ordered 16,000 was the demand, and Barbara only ordered 8,000. In this case, notice the quantity short is correct. It is 8,000 because that's how much you're short by. You should have ordered 8,000 extra, but you didn't, right? That's what you're short by. So it works well when demand is more than order quantity, but then it goes negative, which is not meaningful when it's the reverse. So what you want to do is you want to do max 0 comma B13 minus B14, and in this way, when you do order more than the demand, the quantity short is 0 because there's no shortage. So the max 0 comma the number, what it does is it gives you this number whenever this number is positive. So whenever the difference is positive, it gives you that number. But whenever the difference is negative, 0 is a bigger number than a negative number, so it picks 0. So max 0 comma something is a trick in Excel to make sure we get a positive number when our calculation is positive, but to stop at 0 if our calculation goes negative. So that's what we're doing. And then quantity of excess is going to be the reverse. It's going to be the order quantity minus the demand, right? That's how much excess we have. So we have 8,000 excess. So what if our order quantity was 8,000 and demand was 16,000? Then excess is showing negative 8,000, which is not correct because you can't have a negative excess. So we're going to do the same trick. If excess goes negative, give us a 0. Otherwise, give us that difference. So here you see excess is 0. We have a shortage of 8,000. If you did the other way, where shortage would be 0, excess would be 8,000. So using the max 0 comma trick, we can figure out how much is a shortage, how much is an excess for whatever demand and order quantity there are. Now we can get to our profit calculation. We can find the purchase cost. This is for B2B. How much does B2B spend on purchasing these products? Well, the purchase cost is not going to be based on the sales revenue. It's not going to be based on the demand. It's going to be based on the order quantity, because if you order 24,000, you have to pay the manufacturer for 24,000 whether you end up selling or not. So this times the manufacturer's price, that's how much we spend on purchasing this stuff. And now our profit is simply going to be our revenue minus our cost. So that's straightforward, revenue minus cost. That's our profit. And so profit can be minus 12,000. That's fine. Don't do the math trick here, because we can make a loss. So negative profit makes total sense. Manufacturer's profit now, the purchase cost for B2B is the revenue for the manufacturer. So that is the manufacturer's revenue minus, now what is the manufacturer's cost? Let's open a bracket. Manufacturer's cost is going to be, they're going to produce the order quantity. They're going to produce this much, right? Because that's the order they got to produce 24,000, and producing each one of those costs us $1.5. So multiply that by $1.5. That's our production cost, and our revenue minus the production cost is our profit as a manufacturer. So in this case, under a traditional purchase contract, if demand turned out to be medium, 16,000. If demand turned out to be medium, 16,000, and the retailer ordered 24,000, the retailer ends up in a loss because they have so much excess inventory which they paid for but never sold. But the manufacturer sits on a nice big fat profit because they produce a lot, 24,000, and they sold all of it at $2.5 a piece to the retailer. Okay. Now what we're going to do is, obviously, these numbers could be different. Look, there are 9 possibilities for these two numbers. There could be 8,000, 8,000, 16,000, 8,000, 24,000, 8,000, and so on, 8,000, 16,000. There are 9 possibilities. You could replace these two numbers by each of the 9 possibilities and then record these profits into these cells manually. But we can automate this process in Excel using a tool called data tables. Data tables you should know like the back of your hand, because if you took SCM 512 or SCM 313, which either of the two you should have taken them, or an equivalent course, you would have covered Excel modeling and what if analysis in that course. So you should be familiar with data tables. If you are not, there are tons of great tutorials on Google and YouTube for data tables. So just Google Excel, and there's 2 types of data tables we can do. This is called a one-way data table, which only works on one variable. If you have just one input, let's say demand, and this is not an input to the model. And then there's 2-way data tables, which work when you have 2 inputs. So you want to learn about both one-way and 2-way data tables. So if you have 1 input variable or 2 input variables to your model, you can do this. Here we have 2 input variables, so we are going to do a 2-way data table. So let me show you how to do that. The first thing you do is you take the model output and you put a formula in the corner of your table, the top left cell. You do equals and you select the output. So our output is the retailer's profit. You want to measure that. And then Excel knows that in this data table, I'm going to measure this cell. Whenever you change something here, okay, this cell changes automatically because this cell changes. Okay, so Excel will change these numbers and this cell will change automatically. It will copy it down here. Now you select this whole table, including the top left number, the top left cell, which is the formula or the pointer to the output of your model. Then you go to data, and the same on Windows, you have to go to data, you have to go to what if analysis, okay, and then you go to data table. Okay, now you have to specify 2 input cells. So which cell do you want to replace the values in this row by? That will be the row input cell. And which cell in your model do you want to replace with the values in the column here? That's your column input cell. So row input cell, where do we put demand? You'll see along the row we have demand 8,000, 16,000, 24,000. That's all demand. So this is the cell right here, B13, which has the demand in our model. So we want to select that. We're telling Excel, take these values and plug them into cell B13. Then column, along the column we have our order quantity. So where do we want to plug in our order quantity into the model? We want to plug in our order quantity into cell B14 in the model. Make sure you get this right. If you flip the two, your profit numbers will be off. Hit OK, and voila, Excel ran the 9 scenarios and filled out this table. So you can see that sometimes we make a profit, but as a retailer, sometimes we make a loss. Okay. Now, what is our expected profit for each order quantity? Expected profit means that if we are to order 8,000 and demand has not occurred, we don't know, demand is the future, we don't know for sure what demand it will be, what profit can we expect? So if we play this scenario multiple times, each time we order 8,000, demand turns out to be something randomly, what's our average profit going to be? So to do that, we're going to use the probabilities. We're going to do some product of these profits. Each profit is going to be multiplied by the corresponding probability, and we're going to put dollar signs because probabilities, if we drag down, we don't want the red cell to move. So it's going to be 4,000 times 0.25 plus 4,000 times 0.5 plus 4,000 times 0.25. So that's like a weighted average, and our expected profit is 4,000. If we order 8,000, we're guaranteed to sell the 8,000 because demand is at least an 8,000, and we can't sell more than 8,000 because we only ordered 8,000. So we always make 4,000 profit, and we can drag it down to get expected profit. Okay. So question 1, what is the expected profit if the retailer orders 8,000? That is right here, 4,000. So we go here, we put 4,000. Under contract 1, what is the expected profit if it orders 16,000? We go here, if we order 16,000, expected profit is 2,000. Okay. Under contract 1, what is the expected profit if you order 24,000? So we're taking all 3 expected profit, that's minus 12,000. Okay. Why is the homework asking for all 3 expected profit? Because then it's going to ask you which of these profits is the highest. Under contract 1, what order quantity will BDB choose to maximize its profit? So if Barbara is looking at this data, and she can, right, she knows Excel, she went to Flint, she's going to say, well, it's optimal for me to order 8,000 because whatever happens, I maximize my expected profit. If I order 16,000, I don't make as much money in the long run, and if I order 24,000, I don't make as much money, I make a loss actually, I'm expected to lose money. So even though, notice the highest profit for Barbara is right here, right? The highest chance at making a profit, make sure I call it red, maybe just make it like blue or something. Purple, blue is good. Okay, so the highest profit Barbara can potentially make is if she orders the highest quantity and demand turns out to be the highest, but there's only a 25% chance of this happening, and in the other scenario she makes big losses, so the expected profit is minus 12,000 here. So she's not, this is a very high risk strategy to order so much, but to maximize our expected profit, this would be our strategy as Barbara. So expected profit is being maximized by ordering 8,000 linear feet. Now we go to the manufacturer. Given your answer to the previous question, like 8,000 quantity, what is the expected supply chain profit? So we need to figure out if 8,000 is ordered, what is the profit for the manufacturer, what is the expected profit, and then we can do the supply chain profit. So here again, we're going to do a data table. We said equals, we use the output of the model, which is the manufacturer's profit, because we can also get that from the model. Then we do the same thing. We go to data, what if analysis, data table. Row, we have the demand. So which cell takes the demand? That's this cell. We plug in the demand. And then the column, we have the production or order quantity. Which cell takes the order quantity? That is this cell right here. And here is our profit. So as a manufacturer, we always make a profit whatever order quantity we get, because the excess inventory doesn't hurt us, it hurts the retailer, right? The retailer's problem, not our problem. We get our money from the retailer up front. So if Barbara orders 8,000 because that is her profit maximizing quantity, then manufacturer's expected profit is going to be 8,000, right? So retailer makes 4,000 profit, manufacturer makes 8,000 profit right here, and the supply chain makes a total of 12,000, 8,000 plus 4,000. Okay, the order quantity for various order quantities, there's no calculation here. All I'm doing is I'm just saying equals this. So what is the expected profit for the retailer at 8,000 order quantity? What is the expected profit for the manufacturer at 8,000 order quantity? And then you sum these two up to get the total supply chain profit for 8,000 quantity. Now notice that 8,000 quantity, which maximized the profit for Barbara, is not maximizing the profit for the supply chain, because the supply chain profit is maximized at 16,000. Okay. Order quantity for 18,000. So the whole supply chain can make 18,000 in profit, but they're stuck at making 12,000 in profit because the retailer is not ordering enough. Why is the retailer not ordering enough? Because they are solely burdened. They're the only one who has to take out the burden of excess inventory if there's any excess, which can drive them into losses, right? And so this mismatch in incentives, where the retailer doesn't have an incentive to order the high quantity, is causing the supply chain to lose money. They should be here making 18,000. But notice, if the supply chain makes 18,000, it's only the manufacturer that gets rich. The retailer is doing poorly. And so because the retailer decides the order quantity, the retailer wants to be rich, and so retailer likes this. They want to make 4,000 even though the supply chain only makes 12,000. So what we need to do is for the retailer to reduce their profit from 6,000 but still be above 8,000. If they make 10,000, 12,000, they're still better off than this scenario. So if they reduce some of their profit in 16,000, give it to the retailer so they can make more than 4,000, then everybody will want to be here. The retailer would be here, want to be here because they would end up making more than 4,000 or 4,000 at least, and the manufacturer would want to be here because they would be making more than 28,000, and the total supply chain profit would be maximized. Okay. And so the other contracts allow us to do that. They allow us to incentivize the retailer properly so that we're not stuck here and we can actually maximize the total supply chain profit. Okay, so let's do that next. So that is the expected supply chain profit under the 8,000 quantity is 12,000 right here. So that is the answer for this question. And then we go down to contract 2. So let's go do the contract 2 analysis, which is revenue share. Okay. Now in revenue share, we have one more data point. So first of all, the manufacturer price went down to 1.5 instead of 2.5 like in a traditional contract. And then we have one more data point, which is the retailer keeps how much percentage of the revenue, which is 75%. And I'm gonna copy paste all of this because the data table is going to work in the same way. Okay, so how do we set up the model? Okay, so the sales revenue total is going to be the same like last time. We take the minimum of this number and this number, and we are selling that for $3. So that is the total sales revenue. But nobody gets to keep the total. Part of it will go to the retailer, part of it to the manufacturer. Well, what part goes to the retailer? That's 75% of this revenue the retailer gets to keep. Under this demand and this order quantity, the retailer gets to keep this much revenue. If 75% goes to the retailer, the remaining revenue has to go to the manufacturer. So total revenue minus retailer's share is the manufacturer's share. Okay, so the 48,000 revenue gets split, 36,000 to the retailer, 12,000 to the manufacturer. Quantity short and quantity excess will have the exact same formulas as last time, because all we're wondering about is how much short we are and how much excess we are. So max 0, comma, and then the short is demand minus the order. So if demand is more than the order, you have a shortage, right? And then the excess is max 0. It's going to be how much you ordered minus the demand, because if what you ordered is more than the demand, then you have an excess. Okay, and if you change these numbers, these will adjust accordingly. Now, purchase cost for the retailer is going to be the order quantity. Okay, that's how much they have to pay for, times the manufacturer's price, because the price now is cheaper, so they'll pay less, but that's the purchase cost based on the order quantity. Now, retailer's profit is going to be the revenue for the retailer, okay, minus the cost for the retailer. This is the retailer's revenue share, the share of the revenue they get minus the purchase cost. Right? They still have to pay the price for all of the items they order, but just a lower price now. Okay, and they make 0 profit in this case. Notice if you go here for 16,000 and 24,000, okay, they're making a negative profit, right? But now, because they're buying it not for 2.5, but they're buying it cheaper, they end up breaking even at this. So the risk of the retailer, the risk is less in a way, because the revenue share and the lower price to buy is kind of, the lower price to buy is kind of insulating them against some unsold quantity. Manufacturer's profit is going to be interesting because they have now two sources of revenue. The purchase, whatever the retailer's purchase cost is revenue for the manufacturer, because when the retailer spends 36,000 to buy these feet, that 36,000 goes to the manufacturer. This is revenue for the manufacturer. Plus, they also have this revenue share, so it gets this 12,000. Okay, plus they get, you could just add this number, or you could just do it from order quantity. The order quantity times 1.5, that is how much money they get, minus the cost. What is their cost? Well, the cost is they have to produce the order quantity times the manufacturing cost, so that's going to be their cost. So this is their profit. This is revenue share revenue plus the revenue directly paid to them by the retailer at $1.5 a piece, minus their production cost. Okay, now we can rerun. Now let's make sure the retailer's profit is the right cell. It's cell 26 now, this one, and manufacturer's profit is in cell B27. Okay, and now let's rerun those data tables. What if analysis data table? Row, we have the demand, so demand goes into the row, and the order quantity is in the column, and so that becomes, notice immediately there are 8,000 is no longer maximizing the expected profit for the retailer. Now the retailer will actually order 16,000 because that's what maximizes his expected profit. Let's do the same thing for the manufacturer. Go to what if analysis data table. The row is the demand, and the column values here are for the order quantity. Okay, and then we get that. Okay, so now what would the retailer order? It will order 16,000. This is how much money they would make, and at 16,000, this is how much money the manufacturer makes, and so we get the maximum supply chain profit, 18,000, actually happening, the maximum possible supply chain profit, and this is what the retailer manufacturer makes, and they're better off than before, because previously here the manufacturer was gonna make 4,000 because they were ordering 8,000, and now they're making 7,500. That's more than 4,000, close to doubling their profit. And manufacturer was making 8,000 because of retailer not ordering enough, and now the manufacturer makes 10,500, which is more than 8,000. So both players would be happier in this scenario than in the previous one. Okay, so under contract 2, what order quantity will BDB choose? They'll choose 16,000 because they'll like more profit. What is the expected supply chain profit? For 16,000, the expected supply chain profit is 18,000. Okay. Now we do contract 3. Okay. So in contract 3, there is no revenue sharing. So manufacturer is going to go back to this original price of $2.5 because they don't get a cut of the revenue. But they're providing this return policy to the retailer, where the retailer can return unsold product for $2. So the initial three formulas, sales revenue, quantity short, quantity excess, are going to be just like the first contract. Okay, so we can quickly do those. So the sales revenue will be this is for the end user sales for the retailer, will be minimum of these two, whatever these two numbers are, the minimum of those two is what actually gets sold, times $3. Then the quantity short will be the max zero trick. Shortage equals demand minus order quantity, because if demand is more than order quantity, that's how much you are short. Excess will do the max zero trick again, and excess is if you have more than demand. So if your order quantity is more than demand, that's your excess. Now buyback from the manufacturer, if whatever is excess, that is what gets sold to the manufacturer again. So that's the manufacturer buyback. The manufacturer buyback is going to be like revenue for the retailer, because they're going to earn this $16,000 and they're going to earn this $48,000 in sales. The purchase cost for the retailer is going to be the order quantity times the price the manufacturer charges. Okay, now retailer profit will be their normal revenue plus their buyback sale, the return revenue, the refund they get from returning, minus their purchase cost for the total quantity they purchased initially. That is going to be their profit. Okay, and manufacturer's profit is going to be the revenue they earn. This purchase cost becomes revenue for the manufacturer, because whatever the retailer spends on purchasing, that's the money going to the manufacturer as revenue. So you could do just click this cell, or you could do order quantity times the manufacturer's price. This is going to be the same number. So that will give you the $60,000 revenue for the manufacturer. Okay, minus they are going to have manufacturing cost. They're going to have to produce this much times their manufacturing cost. That's going to be subtracted, and then minus they're going to have another cost. What they have to buy back? They have to buy back the excess. So they're going to have to $8,000. They're going to have to pay $2 for that. So they have to buy that back. So their main revenue minus their production cost minus the buyback money, they have to pay the retailer and buy that stuff back. So that becomes their profit. Then you can just copy paste this data table stuff and rerun the data tables to see what the expected profit looks like. Okay, so we go here, and we want to make sure that the retailer's profit is selected by this data table and the manufacturer's profit is selected by this data table. Notice that when you update these cells, the table does not update. It's not a live table. Excel just runs all the scenarios and copies the values here. They're just normal copied values. There's no formula here. So you always have to reselect the table and rerun the data table if something changes. So go to what if analysis, data table. The row value in this table are demand, and demand needs to be plugged into this cell. And then the column values here are the order quantity, needs to be plugged into this cell. And voila, we have our profit. And again, notice that the maximum profit for the retailer occurs at this quantity, which is more than in the traditional contract. They're only ordering 8,000. On the buyback, Barbara is going to say, oh, let's order 16,000 because I can return for a refund of $2 per linear foot any excess inventory. So I'm less worried about excess. So I'm going to order 16,000, try to get my profits up. Okay, let's do the same thing for the manufacturer. What if analysis, data table. Row has our demand, which needs to be plugged into this cell in our model. Column has our quantity, needs to be plugged into this cell in our model. Voila, we have our profit. And manufacturer's profit is maximized at this quantity as well. However, the manufacturer does not decide the order quantity. Order quantity is decided by the retailer. So this table is used to figure out how much quantity will be ordered in the supply chain, because the retailer decides the order quantity. Manufacturer can give them these different contracts to try to incentivize them to select the right quantity for the whole supply chain, but they can't force them. And then you can see that in the total supply chain profit, if you select 16,000, you maximize the total supply chain profit at 18,000, which was being done by revenue share as well. Notice in revenue share, that makes, retailer makes 7,500 and 10,500. Here is a little bit different. Retailer makes 60,000, manufacturer makes 12,000. But again, notice the same pattern. Compared to a traditional contract, a retailer was making 4,000 because they would select 8,000 quantity. Retailer is making 4,000. Here they're making 6,000. Manufacturer is making 8,000. Here the manufacturer is making 12,000. So both parties are better off. Total supply chain profit is maximized. The conclusion of this analysis is that sometimes when the retailer doesn't want to take on sufficient risk because all the cost of excess inventory falls to them, and the manufacturer is sitting easy and laughing and always in profit, then the manufacturer can try to increase their own profit, the retailer's profit, and the supply chain profit, maximize everything by going to other contracts. It does not mean that these two contracts are always superior. It depends on these numbers. All of these numbers, the cost and the prices and the demand distribution. So you have to do this analysis. Sometimes the traditional contract will turn out to be the best, right? It's not a given that the other contracts are always better. The other thing to keep in mind is the other contracts have additional costs which you have not factored in. So in revenue sharing, there has to be trust. The manufacturer has to trust the retailer. They're going to give them their share of revenue. They're going to account it properly. Maybe they'll ask the retailer to share their point of sale data with them so they can verify they're getting the right revenue share, right? And so forth. In buyback, the manufacturer can try to see what they can do with the returned product and be sold next year, and so on and so forth. So it's not just a flip of a switch. You have to set up systems to handle these two types of contracts, but if you're able to do that and there's some trust between the two parties, sometimes they can both make more money than they were making under a traditional contract. Now, if you had a different demand distribution, okay, you could put a formula here for demand which got the number from the demand distribution, and then you would just have there's a way to do a simulation with a data table where you just put 1, 2, 3, 4 numbers here, and each time you put the number into an empty cell, and Excel re-updates this calculation, and a different demand is used from the demand distribution. So you can convert this what if analysis into a simulation very easily by adjusting the formula here and adjusting the data table a little bit to turn this into a full-fledged simulation. We are going to stick to this a little bit simpler model because it captures all the main points and it captures the main ideas and the logic behind the analysis. So we're going to stick with this. But if you wanted to extend it to a full-fledged simulation, have a proper demand distribution instead of just 3 levels of demand right here, you could do that. Okay. So let's look at the last few questions. So contract 3, what order quantity will B2B choose to maximize its profit? They are going to choose 16,000 because that maximizes their profit at 6,000. Okay, so they will choose 16,000. What is the supply chain profit? That's 18,000. And when they choose 16,000, they get 18,000 total supply chain profit. Which of the following is true? Select all choices that are true. Contract 1 is the best contract as it is simple and other contracts provide no increase in profit. This is clearly wrong because the other contracts do provide an increase in profit. In contract 1, we end up making 4,000 and 8,000 at the 2 companies, but in the other ones, we make more money at the 2 companies. Okay, so first option is wrong. Don't select that. Well, it may not be the first option for you. They could come up in a different random order when you do this. So make sure you read them carefully. But the option that says contract 1 is the best contract as it is simple, which is true, and other contracts provide no increase in profit as compared to it, which is false. The second false part will make the whole statement false, and this is false. This is not true. We will not select this statement. Contract 2 provides a higher level of profit for the manufacturer, Renata, as compared to contract 1. This is true because you can compare. Under contract 1, you would be on this row where the manufacturer would make 8,000. Under contract 2, you would be in this row where the manufacturer would make 10,500. So this is true. Contract 2 provides a higher level of profit for B2B as compared to contract 1. This is also true. You can again compare. B2B makes 7,500 versus under contract 1 they make 4,000. Remember to look at the row on whichever quantity the retailer picks, because that's the quantity that determines which row you're going to be living in. In contract 1, retailer will pick 8,000 to maximize their profit. Under contract 2, the retailer will pick 16,000 to maximize their profit. So you have to look at the row that is being picked by the order quantity that is being picked by the retailer. Okay. B2B makes the highest expected profit under contract 3. So B2B is the retailer. Contract 3, the expected profit is 6,000. This is false because they make the highest expected profit under contract 2. B2B makes the highest expected profit under contract 2. This is true. Total supply chain profit is higher for contract 3 as compared to contract 1. This is true because in contract 1, you're in this row, your total supply chain profit is 12,000 versus contract 3 and 2, where both of the other contracts, your total supply chain profit is 8,000. Total supply chain profit does not change between the contracts. The contracts simply divide the pie differently between the retailer and manufacturer. This is false because, as we saw, that under contract 1 we are stuck in a suboptimal situation where the retailer is not willing to take additional risk that they should take because of the incentives are being misaligned. They have to be stuck with all of the excess inventory cost. When that cost is shared either through revenue sharing or buyback, revenue sharing with a lower purchase price for the retailer, the retailer moves to the optimal quantity for the whole supply chain and ends up making more profit, and the manufacturer makes more profit. So the pie is being expanded by the choice of the contract. It's not that the pie stays the same. It's not that you're only splitting up this 12,000 supply chain profit in various ways. You are actually expanding the pie from 12,000 to 18,000 and then also splitting it up. Okay, and so these are the right options, and that is it. Then you are done.